Okay. We've been dealing with numerical expressions. All these problems we've been simplifying down. These are numerical expressions. They involve numbers and symbols, parentheses, add, subtract, all that kind of stuff. We need to start talking now about algebraic expressions. Okay? An algebraic expression can just look like this, but more often it looks something like this. So what would you say the big difference is between a numerical expression and an algebraic expression? A variable. Okay. So a variable. What's a variable?
Look, it's a number, but you don't know the number.
It's a number. It's a number. That is the big key. Now you guys say it's a letter. And a lot of times people will look at that and they'll say, oh, we have a letter here. But that is not a letter. It is a number. And that's the way you always have to think of it. All right? I hear people say things like, did fine in math till they started putting letters in. Well, no wonder you didn't do too well, because you didn't realize they're numbers! Yes. Right? Okay? Never think, oh, there's a letter. No, it's not a letter. It's a number. Now, do I know what number that is right now? No, it varies. It can be a 4 in this problem, and a 10 in another problem, and a 20 in another problem. That's why we call it a variable. Okay? And you guys, gosh, years ago, in elementary, at some point, your teacher gave you a problem worksheet, and it had a problem like this on it. And I don't think the teacher even explained it to you. They just gave it to you, and you were going along, and Thomas was like, I'm pretty sure a 3 goes there. Isn't that what you thought, Thomas?
Probably thought it was a 4.
Maybe. He was young. We don't know. Okay? And why does the 3 go there? Because that makes it true, right? Okay? Well, empty box is kind of hard to draw. So we don't draw empty box. We use a variable, like some kind of letter. Sometimes we use Greek letters. We'll use a little fish symbol or something like that. It doesn't really matter. We could use empty box or blank space or whatever we wanted. It's just easier to use a letter to represent an unknown number. So we need to understand that. So algebraic expression, it can be really simple. It could just be a single variable like a. Even if it doesn't have a variable in it, we can still call it an algebraic expression, although usually we'll call it a numerical expression. Okay? And what we're going to be doing today is evaluating. We're going to start learning to evaluate algebraic expressions. And we've already been doing this to some degree. Haven't we? Haven't you noticed that when we use a formula, this is an algebraic expression. The whole thing is an equation. All right, but just that part is an algebraic expression. And every single time I've done a problem like this for you, I've replaced the r with a little set of parentheses. So the problem looks like that. And I put the 4 inches inside the parentheses. Have you noticed that I've done that every time? Why do I do that every time? I want it to say what it's supposed to say. Without the parentheses, it doesn't say what it's supposed to say. But with the parentheses, it says 4 times 4 times pi, and it also says inches squared. And that's the way we evaluate an algebraic expression. So you're going to be given problems that simply say something like, evaluate this expression Now what does that say? It says x times m times p. Right? Y'all with me? Don't try to make a word out of it. I don't even know what that word would be. It's what you make when you spit. I don't know. Okay? So don't try to make a word out of it. And then they'll say evaluate this expression if, in this case, x is a 4, m is a 5, and p is a 2. So here's what we're going to do. This is your first thing. You replace every variable with a little parenthesis. A big enough parenthesis that you can fit stuff in there. Okay? And then you put the numbers inside so that it doesn't say 452. It says 4 times 5 times 2. Simple, right? 20 times 2. Could that be a simpler problem? And I bet you guys would have got it correct even if you didn't use the little parenthesis, right? But what's going to happen if you don't use the parentheses and you hand your assignment to Mr. Collard? Am I going to shed a little tear for you? Am I going to hand your assignment back and say, oh, I wish I could give you points for this, but no, not going to happen. And then I'll show you why. Okay? See, check this one out. Evaluate this expression if y is a negative 2 and z is a negative 6. You're not getting this one right without doing it the way I'm teaching you. Okay? When you do this, if you don't replace y with the parenthesis and z with the parenthesis, notice this subtraction symbol, is it still there? Okay? Negative 2 goes here, negative 6 goes here. Notice my negatives are a little bit shorter and they're a little bit higher than my subtraction symbol. Right? So I can tell what's going on. So this says the opposite of 2, subtract negative 6. Are you going to see the double negative stuff going on without the parenthesis? It's not going to happen, is it? Okay? Taj? Am I disturbing you? Sure? You good with? Okay. So we end up with negative 2 plus 6. And this is what I expect to see on your paper.
I would have got that wrong.
Yeah, I would too. It's really hard to keep track of all the signs and the double negatives when you're supposed to be multiplying. It's just really difficult to keep track of it without the parentheses. With the parentheses, though, it says exactly what it's supposed to say. So I'd like you to try this one. And all I want you to do is substitute the values in and use the parentheses. Make your parentheses big enough that you can see your negative symbols and stuff inside of them. Okay? If you make them too little, things don't work out so well. So evaluate this expression if a is a negative 3 and b is a negative 2, or sorry, negative 4. So just do the substitution for me. If you want to, you can go through the whole problem and replace all the variables with parentheses first, and then go back and put the numbers inside of it. Sometimes that's easier.
What did you do? Minus 4 and then
Okay, I'm not worried about the final result right now. What I'm worried about right now is that you're doing this. You follow me? Right? So that when we put -3 in for A and -4 in for B, it says what it's supposed to say. The opposite of -3, subtract -4, subtract -3 times -4. Okay? Make your parentheses big enough and do it neat enough that you can see the negatives, all of that stuff. Because if you miss one sign, you've done the whole problem for nothing. It's all wrong. Right? Okay? We've got to do the whole thing right. So now we can go back to the front and we start doing the problem. Is there anything inside of a parenthesis we can do?
-3 times -4.
Yeah, but is that stuff inside of a parenthesis? Right, so then the next thing is the times. And I'm going to take care of the double signs here. This is the opposite of -3, the opposite of -4. That's on the same level as multiplication. We're basically saying -1 times -3 right here, so we are timesing. And then on the end, positive 12 or negative 12? Okay. Get it down to a single sign. Don't put subtract negative or subtract positive. Just think about the whole thing. There's 3 negatives here, that's negative. Then you can go back and say, okay, 7 subtract 12. Okay? Should we try another one? Let's try another one. Okay, don't do the problem yet, just do the substitution. Where the x is, put a 2. Where a is, put -4. And for the b, replace that with a -6. Just do that part. Okay, when you get that much done, look up at me so I know you're done. Okay, so I hope you did this, yeah? Then subtract. What do you want to do with this? The parentheses that are already here? Do they go away or anything?
No.
And do we want to keep track of them and that they and which ones go together?
Yeah.
I'm going to make them bigger. Then here's A. Here's B, and then what do you think of that? Do you like the big parentheses? If you want to, you can make them into brackets, but you need to keep track of those two and that they go together. Okay? You with me, everybody?
Heck yeah.
Okay. All right. Now what? I don't think I'm going to do anything with that part, but I think we can do something inside the bracket. You guys okay with that? So what do we have in there? Don't we just have 4 subtract 6?
But then there's another negative right there.
No. What? Just inside. Just inside inside that set of parentheses right there. All we have is 4 subtract 6, which is -2. So that's all I'm working on right now is what's inside the parenthesis, correct? Okay, so we get that. Now it says -2 subtract -2. Isn't that -2 plus 2?
That's 0.
Do you see how this is not going to work if you don't do it the way I'm teaching you right now? It's just not, okay? If there were an easier way, I would teach you that. This is the only way it's going to work. So if you're going to be lazy about it, you're just wasting your time. You understand?
Can you do one more?
Oh, I could do 3 more. How about that? Okay.
This is still until the end of class. Still another.
Okay. Evaluate this expression if x is -2, y is a +3, and a is a -4. I'll walk around and help you. You don't need to write down the original problem, okay? Just write it out, replace your variables with the parentheses, and then put the numbers inside. It should say what it's supposed to say. Put those numbers inside where they go. Okay, you guys ready to feel good? When you get this right, oh, it feels so good. So on my paper, I would do this first. Okay? I probably would put the numbers inside as I went along, but for you guys, right now, this is a really good idea. Just do this. Then go back and say, okay, x is -2, y is a 3, and a is a -4. Everyone happy with that? Now, let's start working this problem out. I'm not going to do too much at once. I'm just going to look inside the parenthesis there. What do we have? +4 plus negative 2? Positive 4 subtract 2, isn't that just 2? That's not hard, is it? Okay. Well, now what? Negative 2 minus 3? Is that what we should do next?
Yeah.
No.
Or should we say negative 3 times 2?
For the
Then we need to do multiplication next? So it should be subtract 6, and that's negative 8. Who got that right? Oh, doesn't that feel good? Who knows what they did wrong? Okay, don't do that again. Let's try not to make that same mistake twice. Here, I'll give you an easy one. This will just take you a second. Evaluate this expression, this algebraic expression, if x is a negative 3 and y is a negative 5. Okay, ready to feel good? That good feeling about yourself, like, I'm smart. I can do this. Who did that right? Look, everyone. Yeah? Gracie? Okay. Put a negative 3 here, put a negative 3 here, put a negative 5 there. Who did that right? Man, you guys are smart. Good job. Okay, now, we don't want to go negative 3 plus 3 yet, do we? No. This negative 3 here, it doesn't even really need the parenthesis. I'm looking over here. Are we going to put plus 15 or subtract 15?
Subtract 15.
Very good. You don't mess around. We've got 3 negatives there. It's negative. So we have negative 3 plus negative 15. That's negative 18.
What?
What were you thinking?
I subtracted.
Oh, you got it now? Who did it right?
Me.
Yeah! Awesome.
That's my boy.
Let's try another one.
Oh.
Evaluate this expression when m is a 5 and p is a negative 2.
Oh.
Oh.
Yeah, I did that one. To be honest.
Negative 16 here?
Add two.
So, I just concentrated on inside the big parenthesis here. I thought of that as negative 10 plus 2, which is negative 8. So that's all I did. Then I thought, oh, I need to multiply next, so the opposite of negative 2 times negative 8 is negative 16. Right? 3 negatives. So 5 subtract 16 is negative 11. Who did it right? Oh, doesn't that feel good? Who knows what you did wrong? Okay, that's good too. Okay, you got to know what you're doing wrong.
Another one?
Yes.
We take a nap.
You need a nap now?
Yeah.